Okay, welcome back to Spot On Weather. And we're going to continue this discussion on the 2017-2018 winter forecast for Southeast Virginia. So, as I ended the last part one of the video, we were talking about the importance of ACE, or accumulated cyclone energy, and where we are this hurricane season, 219.5 as compared to the normal 90.1 number. All right, so the implications for the upcoming cold season or winter season across the Western Atlantic Ocean, simply put, with all of the potential energy being utilized in the heat redistribution, we expect less nor'easters this winter. We had a very quiet nor'easter season last winter, and we expect the same again this winter. So that's just something to keep in mind, and that's going to really tie in heavily to our precipitation forecast. Looking at the hurricane summary, this chart, this is the Northern Hemisphere tropical cyclone activity for 2017. And there's a lot of useful values here. The one thing I wanted to mention is, again, the accumulated cyclone energy ACE across the North Atlantic Basin right now is 219.5 as compared to the climatological norm at 90.1. As you can see, major hurricane days in the North Atlantic, 19 this year. 19.25 actually. The normal is 5.6 major hurricane days. We've had 6 at this point. Hurricane days 50.25, which is more than double than the average 20.5. We've had a total of 10 hurricanes at this point, and just it's an amazing thing. We have 5 major hurricanes, including 2 Category 5 storms this season. So it's been a very busy hurricane season across the North Atlantic Basin. And here's some of the tracks for the hurricane season this year. We started off the year with Arlene in April, which was well before the June 1st start of the hurricane season. I'll go over here, and you can see Arlene started things off. Then we had Tropical Storm Brett, Cindy, and then Don and Emily. And then we had Hurricane Franklin, Gert, and then Harvey, Irma, Jose, and Maria were big ones for us. Obviously had some impacts. Harvey across Texas. And then we had Irma going up the west coast into Florida. And then we had Jose, which lasted a long time. Jose was out there for quite some time, from the 5th to the 22nd of September. And then we had Maria, which really hurt. Basically, Category 5 went over the top of Puerto Rico. So here are the actual tracks of the hurricanes. The red line indicates that at that point, the red indicates that we were dealing with a hurricane. More of a purple color here indicates a major hurricane, which is Category 3. 111 mile per hour winds are stronger. It's been a very busy season. All right, now we're going to turn to a colder subject in our winter forecast considerations, and that is the Siberian snow cover. And according to Dr. Judah Cohen of Atmospheric and Environmental Research, or AER, his research has shown that increased snow cover over Siberia in October leads to severe winter weather across the mid-latitude continents eventually. And the early increase in snow cover results in much colder air masses forming on top of that snowpack over Siberia, which eventually propagates towards the U.S. on a cold northwesterly jet stream wind, deeper troughs, especially from the Rocky Mountains east. Long-wave blocking patterns result in extensive cold air pouring over the eastern United States from higher latitudes, while ridging typically occurs over the western U.S. during these situations. We do at Spot On Weather definitely concur with Dr. Judah Cohen's extensive analysis and assessment in this particular area. He's done a lot of good work, a lot of great work actually in this whole situation, the whole area. I will share a link from Dr. Judah Cohen where you can look up he does blogs weekly on that topic. Current snow cover right now is slightly above normal for October standards across Siberia, and here's a chart to prove it. Right now we're looking at these blue areas and the brown areas. This is Siberia, and right now the blue areas indicate plus 5 to plus 25, 5 to 25% above normal snowpack over Siberia. So it's just something to keep in mind. And this is versus the 1981 to 2010 climatology. So these are departure from normals of snow cover over Siberia. And again, what happens is with snow cover and a snowpack, you get stronger radiational cooling, and you get much colder air masses to develop over the top of snowpack. And over time, throughout the winter, the jet stream pattern eventually shifts from Siberia, comes across Alaska, drops down, forms a huge trough over the eastern United States, and that just opens up the floodgates of this cold, dense air to flow straight down to the eastern U.S. All right, we also have to talk about teleconnections. Now, this is an interesting topic. If we talked about the AO phase, the Arctic Oscillation, generally what happens during a positive AO is you get these purple areas represent, basically you have lower heights over Canada and higher heights over the eastern United States. Whereas if you have a negative Arctic Oscillation, you actually get higher heights to go build over the top, over Canada, over the polar areas, and then you have lower heights associated with troughing over the mid-latitudes of the United States. With the North Atlantic Oscillation, when you have positive phases, positive NAOs, you have generally higher heights off the eastern United States, above average heights over the western Atlantic. And then with the positive, as far as temperatures go, you have much milder temperatures with the North Atlantic Oscillation. Now it's the reverse for the negative North Atlantic Oscillation. It would be the reverse pattern where it would be colder with lower heights over the east. And then the Pacific North American pattern, that's a situation where with a positive PNA, you get a ridge across the west and a trough and colder temperatures across the eastern United States. And then with the surface temperatures, that correlates to much colder or below normal temperatures across the east with a positive Pacific North American pattern. Again, it's the opposite. If you have a negative Pacific North American pattern, you're actually going to have the reverse, where you're going to have a trough, cooler temperatures in the west, and a ridge and warmer temperatures in the east. And then we also have to look at the Madden-Julian Oscillation phases, MJO phases. And generally what favors for December, January, and February meteorological winter, phases 8, phases 1, and phases 2 show a lot of blue. That generally indicates colder than normal temperatures. And then if the MJO goes to phase 3, especially 4 and 5, 6, and even 7, 5 and 6 being the warmest, if the MJO is in those phases, then you have much above normal temperatures across the Midwest and Eastern United States. Now I will mention this about teleconnections. When the North Atlantic Oscillation and the Arctic Oscillation are negative, along with a positive Pacific North American or PNA pattern, and MJO phases 8 through 3 are achieved, then you generally have colder than normal temperatures which impact the eastern United States. When the North Atlantic Oscillation and Arctic Oscillation are positive, along with a negative PNA pattern and MJO phases 3 through 7, now you have warmer than normal temperatures across the eastern U.S. And then at times, one thing to really emphasize is at times the teleconnections counteract each other, resulting in near average temperatures. At other times, certain teleconnections outweigh others, favoring a specific weather regime, either warmer or colder than normal temperatures. So it all depends on how all these teleconnections come into play. What are they, positive or negative phases? That's going to be the key. What number phase are we in for the Madden-Julian Oscillation? Sometimes they work together in unison and compound and basically help each other. Other times they work against each other. And then finally, my last discussion is going to be on the sea surface temperature anomalies. This is as of 0800 Eastern Daylight Time, October 16th, and I want to point out a few particular areas where the temperatures are below normal. I mentioned this already in a previous slide in part 1, where this blue indicates colder than normal temperatures over the equatorial East Pacific off the coast of South America. This is indicative of a La Nina, and this is why there is a La Nina watch in effect. There's other cold areas west of Australia. There's another cold pocket just to basically north of Japan over the western Pacific. We have above normal temperatures that are situated south of the western Aleutian Islands in the northwest Pacific. We have colder than normal temperatures sitting off the west coast of the U.S., particularly California. And then we have above normal temperatures situated off of New England. Now I drew these blue H's and this semi-red low pressure to indicate, based on surface temperatures, where the ridges and the troughs will form. Upper level ridges or higher heights tend to like warmer surfaces, and generally you're going to have you're going to have an amplified weather pattern or jet stream to where you have a huge ridge over this warmer than normal temperature pattern out over the western or the northwest Pacific Ocean basin. And over cooler surfaces, you generally have troughing, which would indicate more of a troughing pattern possibly for the upcoming winter off of California, and then a ridging pattern again associated with this blue H, this upper high, over the eastern United States. So this is our official forecast, our official winter forecast for Southeast Virginia this year. Taking into account all the factors we discussed, Spot On Weather is expecting near to slightly above average temperatures for the winter. For snowfall, we're expecting slightly below average. We're projecting 3 to 5 inches of snow for the winter. The average snowfall again is 7 inches. Here's our reasoning and thinking into it all. So in summary, taking into account La Nina conditions, the very active hurricane season, we're expecting less nor'easters or coastal lows. Siberian snow cover right now in October. Teleconnection patterns and sea surface temperature anomalies, where these patterns are setting up, these anomalies. We are forecasting a near to slightly warmer winter with slightly below normal snowfall. And keep in mind that strong La Nina winters, again, have also produced some memorable snowstorms. We talked about this earlier, how we had the top three out of the top 15 snowstorms in Norfolk have occurred during strong La Nina winters. So, but based on all these factors, okay, the emergence of La Nina and how the weather pattern sets up, sea surface temperature anomalies associated with La Nina, the model La Nina forecast, we're expecting a weak La Nina based on the latest model runs in accordance with the Climate Prediction Center. We look at the overall patterns here. Again, this outlier here with a stronger La Nina, some record snowstorms for Norfolk. The active hurricane season and how there's an energy void, as most of the warm season or hurricane storms have taken up a lot of the potential energy in the Atlantic Ocean basin. High ACE values are very, very high, 219.5. And then we looked at Siberian snow cover, Dr. Judah Cohen. Current snow cover departures right now from normal over Siberia, teleconnections, and there it again is that. Here's our references we use for this video, so we'd like to thank the following for references that we were able to utilize in constructing this year's winter forecast. Jan Null, Certified Consulting Meteorologist, the NOAA Central Climate Prediction Center, the National Weather Service Wakefield Office, and then the Atlantic Tropical Summary, Colorado State University, Dr. Cohen of AR and North Carolina State University. That wraps up the winter forecast from Spot On Weather. If we're not spot on, we're not doing it right. Have a great evening.